Welcome to this strategic guide on modeling the ripple effect. We are exploring how to quantify the impact of self-sovereign identity, or SSI, within the supply chain. Using the Ziraai platform as our primary case study, we will move beyond technical implementation to understand the systemic changes this technology creates. From qualitative promise to quantitative proof. While SSI promises abstract benefits like privacy and efficiency, businesses need data to justify adoption. We must answer critical questions. How does it affect process cycle times? Where will the bottlenecks appear when we scale to thousands of farmers? By using simulation modeling, we transform these speculative questions into a predictive, data-driven analysis. Choosing the right lens to see the future. To model this accurately, we use two distinct lenses. Agent-based modeling, ABM, is a bottom-up approach that simulates individual actions, like a specific farmer interacting with a bank, to see how system behavior emerges. System dynamics, SD, is top-down, focusing on high-level stocks, flows, and feedback loops to understand long-term policy impacts and trends. The anatomy of our supply chain digital twin. Our model is a digital twin of the Ziraai architecture. It mirrors our three-tier system. Tier 1, the Hyperledger Indie Ledger, acts as our rulebook and trust anchor. Tier 2 is the mediator and infrastructure, our communication backbone. Tier 3 contains the intelligent agents, the issuers, holders, and verifiers, each with their own distinct decision rules and behaviors. Modeling the flow of trust creation. We first model the issuance phase. In a baseline scenario without SSI, this involves manual applications and physical document delivery, often plagued by error rates and database lags. In the Ziraai scenario, we track specific parameters like connection time and ledger write time as the issuer defines a schema and sends a digital credential offer directly to the farmer's mobile wallet. Modeling the flow of trust in action. Next is verification. The key insight here is the zero-knowledge proof (ZKP) process. Instead of manual document checks, the farmer's wallet finds the credential and generates a proof locally using CL signatures. This decouples verification from the original issuer, enabling automated 24/7 trust validation that we measure through ZKP generation time and network latency. Approach 1. The agent-based model, ABM. In our ABM, we define the attributes of every participant. For example, a farmer agent might be in a state of seeking loan, triggering a query to a bank agent. The model accounts for variables like the farmer's device type, which affects how fast their phone can generate a proof. The primary outputs here are the distribution of loan approval times and queue lengths at the ministry or bank. Observing emergent behavior. When we compare the simulations, the results are dramatic. Without SSI, inefficient manual communication creates system-wide bottlenecks, resulting in an average verification time of 48 hours. With Ziraai's SSI model, we see fluid, scalable operations where verification takes less than 10 seconds and the fraud rate drops from 5% to near zero. Approach 2. The System Dynamics (SD) model. Shifting to the SD model, we map the feedback loops driving the ecosystem. We track stocks, such as the total number of active farmers with wallets. We observe a reinforcing loop, R1, where more active farmers attract more banks, which in turn increases the value of the credentials, accelerating the farmer adoption rate even further. Testing strategic levers with what-if scenarios. The SD model allows us to test what-if scenarios that technical specs can't answer. For instance, if we onboard 2 major banks at month 6, we see a sharp inflection point in farmer adoption. We can also simulate the system-wide impact of rural connectivity issues or low farmer tech literacy to identify where the system might fail to reach critical mass. Which model for which question? Choosing between models depends on your goals. Use ABM for high granularity questions about operational details and where queues will form. Use system dynamics for high-level policy impacts and to determine the most effective strategy for driving adoption over a 3-year period. Fueling the model. We fuel these models using internal Ziraai documentation for performance benchmarks, such as connection and issuance timings. We also include system limitations as variables, such as ledger performance delays. These are supplemented by external business assumptions regarding current fraud rates and farmer literacy. From concept to insight, a roadmap. Our roadmap follows 4 steps. We start by gathering baseline data on the current manual supply chain. Then, we deconstruct the Ziraai system into agent behaviors. After implementing and calibrating the model in software like AnyLogic or Venzim, we run experiments to generate strategic recommendations. A predictive engine for trust. In summary, simulation modeling transforms Ziraai from a technical platform into a predictive tool for strategic decision-making. ABM helps us understand tactical, individual-level behavior, while system dynamics lets us explore long-term ecosystem growth. Our existing documentation provides the high-fidelity blueprint needed to accelerate this journey from concept to insight. The path forward. To begin, we recommend 3 immediate steps. First, prioritize your core strategic question. Is it operational efficiency or market adoption? Second, initiate baseline data collection on your current without SSI workflow. Finally, convene an agent behavior workshop with architects and analysts to map out the detailed decision logic for our farmers, issuers, and verifiers.